I suppose it's something we really need to master in our study of chemistry, is how we can use valency in writing formulas. And I'd just like to remind us of what we've already found out, that the major long groups, which is got shown here on the front, have a valency or a combining power that is totally linked to their column. And we see these all the way across. We start off with hydrogen, and hydrogen is with lithium, sodium, potassium because at very low temperatures it takes on a metallic role and it acts very similar to those elements. It also has one valence electron, which helps put it in that spot. Right, column 2 in the yellow has 2 valence electrons and a valency of 2, combining power of 2. The main one in 3 that we look at is aluminium, which is below the B, and then we look at carbon and silicon, which have a +4, -4. That's to do with a lot of things going on with them. Then we've got nitrogen and phosphorus. We look at them having a valency of 3, oxygen, sulfur, 2, and then fluorine, chlorine, bromine, and iodine of 1. And of course, our inert gases do not have 1. So the valency reflects, as we've seen, there's a link to the electrons, especially the electrons in the outermost or valence shell. There is a link to the charge on the ion, which is also linked to the electron structure and the number of electrons in the outer shell. And of course the combining power, or how much the ratio I need to combine with other elements. So let's use this information now to decide the ratio of elements to form particular compounds. And we're going to treat the complex ions, as I've said before, we should be treating the complex ions as if they were a single element. And we look at those a bit more closely in the examples we've got. So let's consider potassium and chlorine. Potassium is in group 1, so has a combining power of 1. So this is combining power of 1. And chlorine also is in group 7, and as we've seen before, that gives it a combining power of 1. So what we do when we mix these into a compound called potassium chloride is the combining power can go down after this one. So potassium's combining power would go here, chlorine's combining power of 1 goes here, but because the numbers are 1, we simply use the symbols. That implies 1. That implies 1. So the correct formula of potassium chloride would be KCl. Alright, let's look at a second one. This time I've got potassium combining with a complex ion called nitrate. Now the combining power of potassium in group 1 is still 1. The combining power of nitrate is the same as the charge on the ion, which is 1. So again, we've got a 1-to-1 relationship. So when these two join to make potassium nitrate, the 1 from the nitrate goes here. The 1 from the potassium goes after the nitrate, 1. And we know that the K tells us there is 1 potassium. The NO3 tells us there's 1 nitrate. So the correct formula would be KNO3. And that is how we use valencies to do formula. So let's keep going. Now, we're going to change it up a bit. So far we've had 1-to-1 relationships. Let's look at what happens if the relationships are not 1-to-1. Again, we're still using potassium, combining power of 1. This time we've got the complex ion sulfate. Now, sulfate has a combining power or a valence, ionic charge of 2 minus, so its combining power is 2. Right? Potassium's combining power is 1. So when we put them together, we take the combining power of 2 from sulfate and put it behind potassium. So now that says me I've got 2 potassiums, and we have the combining power of 1 goes here, so we've got 1 sulfate. So 2-to-1 is my ratio. So I show it as K2SO4. We don't write 1, just because SO4 implies 1. and it's the same. So potassium sulfate would be K2SO4. Are we seeing a pattern yet? Right, let's make it even trickier. So we've got aluminium sulfate this time. So our combining powers, aluminium, group 3, charge on the ion 3 plus, so combining power of 3. Sulfate, charge on the ion 2, combining power 2. So when we put them together, with the 2 from the sulfate goes after the aluminium. So we show it as Al2. So I've got 2 aluminiums, 3 sulfates. Notice I've had to use brackets here, because if I don't have brackets, that becomes SO43, and that is not sulfate. As we've learned, every complex ion and every compound has a particular ratio of the elements involved. If you change that ratio, you are not talking about that compound or complex ion anymore. So we have to use the brackets to make sure that we're talking about sulfates. So around the brackets, and we have the 3 on the outside, says we've got 3 of what's in the bracket, or sulfates, for every 2 aluminiums. And I hope that makes things nice and clear, and you're able to do more examples of this as we progress through our studies of chemistry.